Hi, in this video, we are going to see about the FCFS scheduling algorithm with different arrival time and with idle CPU session. So in the previous videos, we saw about the FCFS scheduling algorithm, how it works with different arrival time as well as how it works with the zero arrival time. So if you want to know about those things, you can go and refer the previous video. In this particular video, we are just going to see about how this same FCFS scheduling algorithm works with different arrival time, and in between we will be having some idle CPU sessions. How to handle that, we'll be seeing it in this particular session. So first, they have given the set of process, and each and every process has the set of arrival time and the burst time. So once this is given to you, the first step you need to do is the construction of the Gantt chart. Okay, so first I'm going to construct the Gantt chart for this particular set of process. So let me construct the Gantt chart first. So as you see, which process is coming in first? Here P1 arrives at 5th millisecond and P2 arrives at 7th millisecond and P3 only arriving at the 0th millisecond. That means your P3 is the process that comes in first. So P3 is available in the ready queue first. So that P3 is given to the CPU for execution. So P3 I have, that is coming in first at the 0th millisecond, and it is executing till 4th millisecond. Okay, until 4th millisecond your process P3 is executing in the CPU. So once this is done, the next process we need to take, and it has to be given to the CPU, the CPU scheduler. It has to take the next process from the ready queue and it has to be given to the CPU for its execution. Now the CPU scheduler will go and see the ready queue which process is available. As of now, if you see, there is no process that is available in the ready queue. Why? Because your P1 arrives at 5th millisecond, your P2 arrives at 7th millisecond, P4 arrives at 7th millisecond, and P5 arrives at 6th millisecond. But your process P3 got over at the 4th millisecond itself. But your process P1 arrives at the 5th millisecond only. Right now, there is no process available in your ready queue that can be given to the CPU. So now in this particular case, your CPU is idle for 1 millisecond. It is idle for 1 millisecond because there is no process that is available in the ready queue that can be given to the CPU for its execution. So your CPU is idle for 1 millisecond. And in this case, now the CPU scheduler will go and see, and it finds out P1 is available in the ready queue. Now this P1 will be given to the CPU for execution. Now P1 will come in and it executes till 6 milliseconds. So 5 plus 6, it will be 11 milliseconds. And the next, at this point of time, right now in ready queue, your process P2, P4 and then P5 are available. Okay, you have three processes available in your ready queue. Now it is the aim, or it is the duty of your CPU scheduler to find out which process can be given to the CPU for execution. Now your CPU scheduler will see which is having the least arrival time. So as you know, the least arrival time is for process P5 because process P5 takes 6 milliseconds. Okay, so it arrives at the 6th millisecond. That's why your process P5 is having the minimum arrival time. So it will take the process P5 and give it to the CPU for execution. So how far it is going? So your P5 takes 5 milliseconds for execution. So 11 plus 5, it will be 16. And then now once again your CPU scheduler will see what are all the process that is available in the ready queue. Now as you see, you have two processes available in your ready queue, that is your P4, P2 and P4. In this, it has to find out which can be given to the CPU first. Now it will come and see the arrival time. Now if you see the arrival time of P2, it is 7. And if you see the arrival time of P4, it is also 7. So both or having the same arrival time. In this case, how the CPU will decide which process can be given to the CPU? Now the scheduler will think about it. Okay, so because both your P2 and P4 are having the same arrival time, now the scheduler has to decide which process can be given to the CPU for execution. So once, if you have two process with the same arrival time, okay, if you have two process with the same arrival time, in that case you need to see the process IDs. Okay, the process ID which is having the minimum process ID. So P2 is the minimum process ID. Okay, so now the CPU scheduler will decide it can give the P2 to the CPU. Okay, P2 to the CPU. Now scheduler will take this P2 and it will give it to the CPU. Now P2 executes for how many milliseconds? 3 milliseconds. So it is 16 plus 3, it is 19. And finally your P4 will come in. Okay, your P4 will come in. It is executing for 2 milliseconds. That means it is 19 plus 2, it is 21. So this Gantt chart is over. Once the Gantt chart is over, as you know, you need to find out the completion time. Okay, completion time of each and every process, that you can directly find it from this Gantt chart itself. Okay, so here you see your process P1, it gets completed at 11th millisecond. Okay, 11th millisecond your process P1 is getting over, and your process P2 gets over at 19th millisecond, and then your process P3 gets completed at 4th millisecond, and your process P4 completes at 21st millisecond, and your process P5 gets completed at 16th millisecond. Okay, so your completion time is over. Once your completion time is over, you need to find out the turnaround time. So as you know the formula for turnaround time. Turnaround time is equal to completion time minus the arrival time. So you just do it. So this is the completion time and this is the arrival time. 11 minus 5. Okay, 11 minus 5, it is 6, and then 19 minus 7. Okay, it is 19 minus 7, it is 12, and then 4 minus 0, it is 4, and then 21 minus 7, it is 14, and then 16 minus 6, it is 10. Okay, so the turnaround time we found out, and the next thing we need to find out is the waiting time. So how we will find out the waiting time? Waiting time is nothing but the turnaround time minus the burst time. Okay, turnaround time minus the burst time. You know the turnaround time and you know the burst time. So as you see, for process P1, your waiting time is 0. 6 minus 6, it is 0. Why it is 0? Why it is 0? Because when your process P1 arrives, before that your CPU was idle. Okay, your CPU was idle. So once the process P1 comes in, it is given the CPU immediately. That's why your process P1 is 0. Okay, your process P1 is 0. As you see in this Gantt chart itself, we can able to understand that when process P1 comes, before that your CPU was idle. That's why the process P1 has been given the CPU immediately. That's why your waiting time for process P1 is 0. And what about the waiting time of process P2? It is 12 minus 3. It is 12 minus 3. So 12 minus 3, it is 9. Okay, and for process P3, it is 4 minus 4, it is 0. Why it is 0? Process P3 is the first process to enter in. Okay, because at the 0th millisecond your process P3 is coming, it is the first process to enter in. So here if you see, before that your CPU is not doing any execution, it was idle. So once the process P3 comes in, it is given the CPU immediately. That's why it is 0 for process P3 also. And then the waiting time for process P4 is 14 minus 2. Okay, it is 14 minus 2, it is 12. And then waiting time for process P5 is 10 minus 5. Okay, 10 minus 5, it is 5. So we found out the waiting time for each and every process. Now what we need to find? We need to find the average turnaround time. Okay, so you know the turnaround time for each and every process, add everything, divide by the number of process. So here 6 plus 12 plus 4 plus 14 plus 10 divided by the total number of process, that is 5. So how much you will get? You will be getting 9.2 milliseconds, and then you need to find out the average waiting time. Okay, so average waiting time, how you will find out? It is 0 plus 9 plus 0 plus 12 plus 5 divided by 5. Your average waiting time is 5.2 milliseconds. Okay, so average waiting time per process is 5.2 milliseconds. Okay, this is how your FCFS scheduling algorithm works with different arrival time and with idle CPU sessions. Thank you.